When was the last time you actually looked at the engine powering your life? You likely have it in your pocket right now, and on your wrist, and maybe even in your car. We're talking about ARM. How does a tiny British laboratory, which barely makes its own hardware, end up 95% of the global smartphone market? It is a paradox that defies everything we know about the tech industry. While giants like Intel were busy building massive, power-hungry cathedrals of silicon, a small team in Cambridge was building a minimalist shack that would eventually outrun them all. They did not want to be the biggest. They wanted to be the most efficient. This is not just a story about microchips. It is the story of how a company that almost went bankrupt in the 1980s became the invisible backbone of the digital age. Today, we pull back the curtain on the architecture in every pocket and the chess move that changed computing forever. The year was 1983. In the outskirts of Cambridge, a company called Acorn Computers was facing a wall. They needed a new processor for their next generation of student computers, but the market was failing them. The chips available from standard suppliers were either too slow or too complex. So they decided to do something completely insane. They would design their own. Led by Sophie and Steve Furber, the team looked toward a radical new philosophy called RISC, or Reduced Instruction Set Computing. While others thought more was better, the Acorn team believed that less was more. They wanted a chip that did fewer things but did them with incredible speed and minimal energy. Wilson designed the instruction set in just a few days, reportedly on pieces of paper. When the first prototype was powered on, it did something that shocked the engineers. It used so little power that it worked even when not fully plugged in, drawing tiny amounts of electricity from the test equipment. The Acorn RISC machine, or ARM, was born. By 1990, Acorn was struggling to survive. But thousands of miles away in Cupertino, Apple was looking for a miracle. They were working on a top-secret project called the Newton, the world's first handheld personal assistant. But there was a problem. To make the Newton portable, they needed a processor that would not melt through the plastic casing or drain the battery in 10 minutes. Intel could not do it. Motorola could not do it. But this tiny British outfit could. Apple teamed up with Acorn and VLSI Technology to spin off a new venture called Advanced RISC Machines Limited. This was the birth of the ARM we know today. 12 engineers moved into a converted barn in Cambridge to change the world. They had no furniture, so they used their shipping crates as desks. They were scrappy, they were focused, and they were about to create the blueprint for every mobile device in human history. Even though the Apple Newton eventually failed as a product, it proved that ARM's efficiency was the future. As the 1990s progressed, ARM realized they had a problem. They did not have the money to build massive chip factories like Intel did. Building a silicon fab costs billions of dollars. So, they made a strategic decision that was either crazy or genius. They decided they would never manufacture a single chip again. Instead, they would sell the recipe. They became an intellectual property company. They would design the architecture and then license it to anyone who wanted to build their own chips. Samsung, Texas Instruments, and Nokia all signed up. This created a massive ecosystem. Every time a company improved on an ARM design, the whole platform got stronger. Think of it like a chef who does not own a restaurant but sells his secret recipes to every kitchen in the world. Soon, the world was full of ARM-powered devices, and ARM was collecting a small fee on every single one. It was a low-margin, high-volume game that would eventually turn into a mountain of gold. Then came 2007, the year the world changed. Steve Jobs stood on a stage and pulled the first iPhone out of his pocket. Inside that device was an ARM-based processor. While the world marveled at the glass screen and the multi-touch interface, the real magic was happening in the silicon. The iPhone needed to run a full desktop-class operating system while lasting a full day on a thin battery. Only ARM could provide that balance. Suddenly, every phone manufacturer on Earth realized they was in a race they were already losing. Google launched Android, also built on ARM. Within 5 years, billions of people were carrying ARM processors in their pockets. Intel, the king of the PC era, tried to fight back with their Atom chips. They spent billions trying to shrink their power-hungry architecture down to size. But they were too late. The world had already chosen efficiency over raw brute force. ARM had won the mobile war without ever firing a shot. For 3 decades, there was a clear boundary. ARM was for phones. Intel was for real computers. But that boundary began to blur. Apple, frustrated by the slow pace of Intel's improvements, began designing its own ARM chips for the iPhone. Each year, these chips got faster and faster. In 2020, Apple dropped the bomb. They announced they were leaving Intel entirely for their own ARM-based silicon, the M1 chip. The tech world was skeptical. Could a phone chip really power a professional workstation? The answer was a resounding yes. The M1 was not just better, it was a generational leap. It was faster, cooler, and the battery lasted twice as long. This was the moment the traditional PC industry began to die. Microsoft soon followed, pushing Windows on ARM. Even the massive server farms that power the internet began switching to ARM to save on cooling costs. The architecture in your pocket was now the architecture in the cloud. In 2020, a new player entered the scene with a bag of cash. NVIDIA, the giant of graphics and AI, announced they wanted to buy ARM for a staggering $40 billion, a price that later climbed to $60 billion. This sent shockwaves through the industry. Because ARM licenses to everyone, they are considered the Switzerland of silicon. If NVIDIA owned them, would they still play fair with Apple, Samsung, and Google? Regulators around the world went into a frenzy. They feared that one company controlling the DNA of modern computing would be a disaster for competition. For 2 years, the deal hung in the balance, until 2022, when the pressure became too much. The deal collapsed. ARM remained independent and eventually went public on the stock market. It was a reminder that ARM is too important to be owned by just one player. It is a global utility, as essential to the modern world as electricity or water. So, what is the legacy of the little company from Cambridge? Today, ARM architecture is found in over 250 billion chips. It is in the thermostat on your wall, the pacemaker in a patient's chest, and the supercomputer predicting the weather. They succeeded not by being the loudest voice in the room, but by being the most essential. The business lesson here is profound. You do not have to own the factory to own the industry. By focusing on a single, elegant solution to a universal problem, power efficiency, ARM built a moated kingdom that the world's biggest companies now rely on. As we move into the era of artificial intelligence and the Internet of Things, that tiny recipe from 1983 is more relevant than ever. ARM did not just build a chip, they built a standard for the future of humanity. Next time you pick up your phone, remember, you are not just holding a device. You are holding 30 years of invisible British engineering. I hope this deep dive gave you a new perspective on the strategies and the relentless mindset behind these global icons. If you enjoy deconstructing business empires and tech legends in this tech archive style, make sure to hit that subscribe button and turn on all notifications. That way, you will never miss a new blueprint of history. For those of you ready to explore more boardroom coups and technological breakthroughs, I have handpicked 2 videos for you right here on the screen. Click one to keep watching. I will see you in the next one. Thanks for watching.